All right, so today we're diving deep into a paper that has some pretty wild implications for the future of AI.
Yeah, this one's a real head-scratcher.
It's called, get this, the Society of Hive Mind. Multi-agent optimization of foundation model swarms to unlock the potential of collective intelligence.
Kitschy, right.
Very punchy. And it's from Noah Mamie and Susie Shi Rao over at ETH Zurich.
ETH Zurich, always doing cool stuff.
So the big question they're tackling here is, can we make AI smarter? Particularly when it comes to logical reasoning.
The kind of thinking that's still a real challenge for even the most advanced AI.
Right, by having multiple AI models work together like a swarm.
Sort of like, imagine a bunch of really smart specialists all putting their heads together.
And what they found, the real kicker here, is that this approach, which they call SOHM, this framework, actually shows some pretty significant improvements in how AI tackles tasks that require serious brain power, that logical thinking.
But there is a catch.
Oh.
It doesn't seem to help much with tasks that need more real-world knowledge, like general facts about the world.
Interesting. So it's good at figuring things out, but not necessarily at knowing things.
Yeah, kind of a specialized intelligence, you could say.
Okay, I'm intrigued. So let's unpack this a bit. What exactly is this Society of Hive Mind, this SOHM thing?
So think of it this way. Imagine you're trying to solve a really complex problem, something that needs different types of expertise.
Like, I don't know, designing a self-flying car or something.
Exactly. You wouldn't just want one person working on that, right? You'd want a team, a bunch of specialists, each with their own strengths.
Right. You'd need engineers, programmers, designers, maybe even a psychologist to figure out how people will interact with it.
Precisely. And SOHM is kind of like the blueprint for how that team would work together most effectively, how they communicate, share information, and combine their individual skills.
So it's about optimizing the interaction between these different AI models, making sure they're playing to each other's strengths.
Right. And the paper gets even more interesting when they start talking about how they achieve this optimization.
Lay it on me.
They actually draw inspiration from evolutionary theories, specifically the Darwinian and Lamarckian paradigms.
Whoa, evolution in AI, that's deep.
Yeah, they're taking cues from how nature optimizes systems over time through, well, survival of the fittest and adaptation.
So in this case, the fittest AI communication strategy is the one that leads to the best problem solving.
You got it.
It's blowing my mind. Before we get too far ahead of ourselves, can we zoom out for a second and talk about the history that leads up to a paper like this?
Oh, absolutely. You see, the idea of having multiple AI agents or even just multiple AI models working together, that's not brand new.
It's not.
Nope. There's a whole field of research called multi-agent systems that's been around for decades.
Okay, so what's so special about this paper then?
Well, a couple of things. First, the sheer power of the individual agents that we have now, these LLMs, large language models, they're like the super brains of the AI world.
Because of deep learning and that whole transformer architecture revolution, right?
Right. They can process information and generate language at a level that was just unimaginable a few years ago.
So now we can have these incredibly smart agents working together in ways that were never possible before.
Exactly. And second, the tools we now have for orchestrating these interactions, for figuring out how these agents should communicate and collaborate, they've also become much more sophisticated.
And that's where this SOHM framework comes in.
Precisely. It's like moving from a bunch of individual geniuses working in isolation to a highly coordinated team of experts.
So it's not just about more brains. It's about better teamwork.
You nailed it.
All right, I'm ready to get back to this evolution stuff.
Yeah.
So walk me through this Darwinian approach. How does survival of the fittest play out in an AI swarm?
Okay, so imagine you have this network of AI agents, each representing a specific skill or function.
Like different parts of a brain almost?
Kind of, yeah. And they're all connected through these communication pathways, but not all connections are equal.
Some are stronger, more important than others.
Right. Now, the Darwinian approach in SOHM is all about figuring out the optimal configuration of these connections.
Like finding the most efficient communication network.
Exactly. And how do they do that? By simulating evolution.
So they're basically throwing a bunch of different connection setups at the wall and seeing what sticks.
More or less. They start with a bunch of different possible network configurations, and each one is tested on how well it solves a specific problem.
Like survival of the fittest network.
Right. The networks that perform well are more likely to reproduce, meaning their connection patterns are combined and slightly tweaked to create new variations.
Like passing on their good genes.
And this process repeats over and over, with the most successful networks continually evolving and refining their communication patterns.
And eventually you end up with a network that's really good at solving that particular problem.
Exactly. It's like natural selection, but for AI communication.
Fascinating. And how about the Lamarckian approach? How does that differ?
So the Lamarckian paradigm, if you remember, it's all about acquired traits being passed down.
Like, if a giraffe stretches its neck to reach higher leaves, its offspring will inherit longer necks.
Yeah, although we know now that's not quite how it works in biology, it's still a useful concept here.
Okay, how so?
Well, the Darwinian approach in SOHM, it results in a fixed communication network, right? Once you find the best configuration, that's it.
Like a set blueprint for how the AI team should work together.
But the real world is messy, things change, new information comes in, the problem itself might shift.
So a fixed strategy might not always be the best.
Precisely. And that's where the Lamarckian approach comes in.
It's more adaptable.
Yeah. Instead of sticking with one predetermined network, the Lamarckian approach allows the network to change and adapt based on the specific task it's facing.
Like the AI team can reorganize itself on the fly depending on what they're working on.
Exactly. And they do this using a special type of neural network called a graph neural network, or GNN, specifically a graph attention network, or GAT.
And this GAT can basically predict which connections between the AI agents will be most useful for a given task.
You got it. It's like the team has a manager who can quickly figure out the best communication flow for each project.
So it's all about real-time adaptation and optimization.
Precisely.
Okay, this is all incredibly cool, but how did they actually test this? Did they, put these AI swarms through their paces?
Oh, absolutely. They put them to the test.
Using real problems, I hope, not just some made-up stuff.
Real deal benchmarks, yeah.
Which ones?
Two biggies in the AI world.
Yeah.
MMLU and MMLU Pro.
What are those all about?
So MMLU stands for Massive Multitask Language Understanding. It's a huge collection of different tasks, kind of like an AI IQ test.
And MMLU Pro is like the advanced version.
Yeah, even tougher. Designed to really push the limits of AI reasoning abilities.
Oh, real challenge.
And they specifically chose these benchmarks because they wanted to see how well the AI swarms performed on tasks that really require logical thinking.
Versus just spitting out facts.
Right, because remember, that's where they thought the swarms would really shine.
So what happened? Did the swarms blow the competition out of the water?
Well, it's a bit more nuanced than that.
Cool.
On MMLU, the regular one, the swarms, both their SOHM models and another existing swarm model called GPT Swarm, they didn't really do any better than just using a single larger AI model.
So no real advantage there.
Not really. And they think it's because MMLU is more about knowing things, having that broad knowledge base, which isn't really the swarm's forte.
But on MMLU Pro, the tougher one, things were different.
Yeah, on MMLU Pro, the swarms actually did better than the single models, in some cases by a significant margin.
So the more logical thinking required, the better the swarms performed.
Exactly, which really supports their idea that this swarm approach is particularly good at enhancing logical reasoning.
And what about those different optimization approaches, the Darwinian versus the Lamarckian? Did one come out on top?
They both have their strengths and weaknesses. The gradient-based Darwinian approach, which they called Hive Mind DG, it performed really well, even beating that existing GPT swarm model on MMLU Pro.
So it's a solid approach.
Yeah, and they found that adding a little trick called a baseline to their algorithm made it even more stable and effective.
So it's like fine-tuning the evolution process.
Exactly. But the Lamarckian approach, with its adaptability, it's also showing promise, especially for situations where the problem might change or new information comes in.
So both are valuable tools in the AI swarm toolkit.
Absolutely.
This is all so incredibly cool. Okay, so big picture now. What are the real-world implications of this research? What could this mean for, everyday life if this technology keeps advancing?
The possibilities are huge. Imagine, for instance, scientific research where you have these AI swarms helping scientists analyze massive data sets, spot patterns, and come up with new hypotheses.
Like having a whole team of AI research assistants.
Right. Or in finance, where these swarms could help manage complex investments, predict market trends, assess risks, stuff like that.
Or even in something like urban planning, where they could simulate different traffic patterns, optimize energy usage, who knows?
The point is, any field where complex reasoning and decision-making are key, that's where these AI swarms could really revolutionize things.
And the fact that they're using these smaller, more specialized models instead of just one giant, super expensive AI that could make this technology more accessible.
Exactly. It could democratize access to powerful AI tools, making them available to smaller companies, research groups, even individuals.
So it's not just about making AI smarter, it's about making it more available.
Precisely.
Amazing. Okay, time for my favorite part of the show, novel notions. Let's get speculative blue sky thinking here. What are some really out there research ideas that this Society of Hive Mind concept sparks for you?
Okay, here's one that gets me really excited. What if we went beyond just using different types of LLMs in these swarms?
Like not just different language models.
Right. What if we started incorporating AI models that specialize in other things like image recognition, audio processing, maybe even symbolic reasoning?
So a real multimodal, multi-talented AI swarm.
Exactly. Imagine a swarm that could not only understand and generate language, but also analyze images, listen to sounds, even manipulate abstract concepts.
Like a true artificial intelligence almost.
It would be a huge leap forward. And the evolutionary and Lamarckian optimization methods in SOHM could actually be used to figure out how to best combine and leverage these different AI skills.
So the swarm would not only be smart, it would be versatile.
Yeah, like a Swiss Army knife of AI, it could tackle problems that no single AI, no matter how big, could even dream of.
Okay, I love that one. What else you got?
How about this? What if we looked at how these swarms could evolve over time? Not just in terms of their communication patterns, but in terms of their actual knowledge and capabilities.
Like they could learn from experience and pass that knowledge on to future generations of the swarm.
Exactly. You could have these long-lived swarms that accumulate knowledge and skills, constantly improving themselves through a kind of cultural evolution.
It's almost like they would develop their own unique swarm intelligence, almost like a collective consciousness.
That's a wild thought, right? And it raises all sorts of fascinating questions about what it means for an AI to truly learn and evolve.
This is mind-blowing stuff. So to sum up, this Society of Hive Mind framework, it's not just a cool idea, it's a potential game changer for the future of AI.
For sure. It shows us that we might not need to keep building bigger and bigger AI models to achieve real breakthroughs.
Maybe the key is collaboration, not just size.
Exactly. It's about harnessing the power of the collective.
And who knows, maybe someday we'll have these incredible, adaptable, ever-evolving AI swarms helping us solve some of the world's biggest challenges.
That's the dream, isn't it?
It really is. If you want to learn more about this fascinating research, check out the link to the full paper in the episode description below.
And while you're at it, why not ponder this? As these AI systems become more interconnected, how will we ensure that their collective intelligence is aligned with our values and goals?
Food for thought indeed. Thanks for joining us for this deep dive into the world of AI swarms.
It's been a real pleasure.
Until next time, keep exploring the frontiers of machine learning.
And keep those brains buzzing.
See you in the next deep dive.